Hello, welcome to another edition of TutorTube, where Learning Center's lead tutors help you understand challenging course concepts with easy-to-understand videos. My name is Kelly Schmidt, lead tutor for statistics at Learning Center. In today's video, we will explore some of the basic probability concepts that will help you to be successful in your statistics courses. Specifically, we'll look at probability rules and conditional probability. Let's get started. When we talk about probability, we're often concerned with the likelihood of a certain event or outcome occurring. For example, if we're playing cards, I might be concerned with the probability of drawing an ace or the probability of drawing a spade. Each of these scenarios, drawing an ace or drawing a spade, is called an event. In order to save time, we'll often use the notation P of ace or P of spade to refer to the probability of events like this. Okay, so how do we actually calculate the probability of an event? Let's use P of ace, probability of ace, as an example. We know there are 52 cards in a standard deck. Of those 52 cards, 4 are aces. Ace of spades, ace of diamonds, ace of hearts, and ace of clubs. To find the probability of drawing any one of these 4 aces, we simply need to find the value of 4 out of 52, which comes out to 0.0769, or about a 7.7% chance. However, what if I asked, what's the probability of drawing an ace or a spade, which would be written as P of ace or spade in mathematical notation? This question isn't as straightforward to answer. Luckily, we have a formula that will help us. The general addition rule says that if you have two events, A and B, then the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. We usually use the general addition rule when we see the word or in a problem, or when asked to find the probability of A or B occurring. Let's do a practice problem to see how this works. A probability experiment is conducted in which the sample space of the experiment is S is equal to the set A through L, event F is equal to the set D, E, F, G, H, and event G is equal to the set H, J, K, L. Assume each outcome is equally likely. Find the probability of F or G. First off, notice that the equation asked us for F or G. This is a cue that we'll need to use the general addition rule. First, we start off by finding P of F. To get a concrete idea of what we're doing, think of our sample space S as being a bag filled with the letters A through L. P of F is the probability of randomly picking a letter out of this bag and getting one of the letters that are in F, D, E, F, G, or H. So the probability of F is equal to the number of things in F divided by the number of things in S, which is equal to 5 over 12. Similarly, we also find P of G. P of G is equal to the number of things in G divided by the number of things in S, which is equal to 4 out of 12. Next, we need to find the number of items that are in both F and G. The only letter that's common to both is H. To find the probability of F and G, we take the number of things in F and G divided by the number of things in S, which is equal to 1 over 12. In the last step, we use the general addition rule and plug in the values that we found. The probability of F or G is equal to probability of F plus the probability of G minus the probability of F and G, which is equal to 5 over 12 plus 4 over 12 minus 1 over 12. This simplifies to 0.667. So the probability of F or G is equal to 0.667. In addition to the general addition rule, we also have the multiplication rule for independent events and the at least or complement rule. The multiplication rule says that if we have 2 or more independent events, we can find the probability that both of them occur by simply multiplying their respective probabilities together. Written out, the multiplication rule for 2 independent events reads as probability of A and B is equal to probability of A times probability of B. Additionally, we also have the complement, at least rule. The formula for this rule is the probability of at least A is equal to 1 minus the probability of A complement. Essentially, we use this rule if we ever see the phrase at least in a problem. Let's look at an example of how these rules can be used in a typical problem. The probability that a randomly selected cat will live to age 12 is 0.63. Find the probability that 2 randomly selected cats will live to age 12. Okay, so the problem tells us that the probability of a single random cat living to old age is 0.63, or 63%. We can represent this as probability of cat is equal to 0.63. Our scenario for the problem asks for the probability of encountering two random cats, let's call them cat 1 and cat 2, that both live to age 12. We can write this as probability of cat 1 and cat 2. Notice that we're dealing with an and problem instead of an or problem this time. Also, since we're assuming that these cats are random and don't have any influence on each other, we can consider each cat to be independent. Because of this, we know that we can use the multiplication rule for independent events. So probability of cat 1 and cat 2 is equal to the probability of cat 1 times probability of cat 2. This tells us that the probability of both cats living past age 12 can be found by simply multiplying the probability that cat 1 lives, probability of cat 1, by the probability that cat 2 lives, probability of cat 2. Since cat 1 and cat 2 are both random cats, we know that each of these probabilities is the same, 0.63. So plugging this into our formula, we get probability of cat 1 and cat 2 is equal to 0.63 times 0.63, which is equal to 0.63 squared, or 0.37. So there's a 0.37 probability, or a 37% chance, of selecting two random cats that both live past age 12. Okay, now let's look at the next part of the problem. Find the probability that 4 randomly selected cats will live to age 12. This problem is similar to the last one, except now we have 4 cats. The cats are still independent, so the multiplication rule still applies. We can still just multiply their independent probabilities. So again, the probability for each cat is the same, 0.63. So our equation becomes probability of cat 1 and cat 2 and cat 3 and cat 4 is equal to 0.63 times 0.63 times 0.63 times 0.63, which is equal to 0.63 to the fourth, which simplifies to 0.158. Notice that this pattern can be expanded for any number of cats. So if we wanted to know the probability of finding 500 cats who lived past age 12, we would calculate 0.63 to the 500th power. Now for the last part of the problem. Find the probability that in a sample of 13 cats, at least one cat dies before age 12. This is an example of a problem where we can take advantage of the complement rule. Using it, we know that the probability that at least one cat dies is equal to 1 minus the probability that all 13 cats live. We can write this out as probability at least one dies equal to 1 minus probability that all 13 cats live. Now, all we need to do is calculate the probability that all 13 cats will live past age 12 and plug this value into the formula. Luckily, we know from earlier parts of the problem that this probability will just be equal to 0.63 to the 13th. We can plug this into the formula and solve to get 1 minus 0.0025, which simplifies to 0.9975. So we know that the probability of at least one cat dying before age 12 in a random sample of 13 cats is roughly 99.7%. Finally, we have one more important rule, the Conditional Probability Rule. We use this rule when we can't assume that two events are independent. For example, if the two cats in the last problem had been siblings, the probability of one cat living longer might have been influenced by the other cat, which means they wouldn't have been independent. Formally, the conditional probability rule is written as probability of A given B is equal to probability of A and B divided by probability of B. The key phrase for problems that use the conditional probability rule is this word given. The probability of one event, A, happening, given that another event, B, has already occurred. Let's look at an example of a problem that uses the conditional probability rule. So, given a sample of 258 people, the following table was created. Find the probability that a randomly selected individual was never married. For this first part, we don't need the conditional probability formula. We just need to set up a simple ratio. Probability of never being married is equal to the total number of people who have never been married divided by our grand total. From the table, we can see that the total number of people who were never married is 83. The grand total is 258. So we have the probability of never being married is equal to 83 out of 258, which is equal to 0.322. Now for part 2, we're asked to find the probability that a randomly selected individual was never married given that they are male. Notice the keyword given in this question. This is a cue to use the conditional probability formula. So we need to find two things, the probability of never being married and being male, and the probability of just being male. Let's start with probability of male. We can find this the same way that we found probability of never married in the first part of the question. Probability of male is equal to the total number of males divided by the grand total, which is equal to 126 over 258, which is equal to 0.488. Next, let's find the probability of never married and male. The ratio we need here is the number of people that are both male and never married divided by the grand total. The number who are both male and never married is found in the upper left box, in the intersection of both categories, 44. So our equation becomes probability of never married and male is equal to 44 divided by 258, which is equal to 0.171. Now, for our final step, we plug those two values into the conditional probability formula. 0.171 divided by 0.488 gives us 0.349. So we know that the probability of selecting an individual who's never married, given that they are male, is roughly 34.9%. And with that, we've covered 3 of the most common general probability concepts. Thank you for watching this TutorTube presentation. I hope you enjoyed this video. Please subscribe to our channel for more exciting videos and check out the links in the description below for more information about the Learning Center, and follow us on social media. See you next time.